Good morning, my YouTube viewers. It's Crystal here. I'm just here this morning because I wanted to give you a code review, and this is code review on Kaggle's Playground series, Season 3, Episode 22, and basically what it is you're predicting the health outcome of horses. And so what I decided to do was, rather than using a model from sklearn, and rather than using a neural network from Keras TensorFlow, I decided to use the Naive Bayes Classifier written only in Python. And so I only got a 56% accuracy, but that's better than the accuracy that I got from Jax's logistic regression, and it's better than the accuracy that I got from sklearn's Gaussian NV, which is a Naive Bayes classifier as well. I'd also like to say that I've been working on JAX, but one thing that I found out about JAX is they have immutable arrays, and one of the algorithms that I had for a Naive Bayes classifier had where you had to update arrays, and it wouldn't work on JAX because they have immutable arrays. So I'm going to have to learn more JAX. I'm going to have to make it my business to learn more JAX, to learn how to get around these immutable arrays. You can get around it by using the .at helper, but I don't know that much about JAX, and so I decided that I will experiment with that another time. So what we'll do is we will get on with this code review for Kaggle's playground exercise, predict the health outcome of horses. So we go through our problem statement is predict on the health of a horse. And the health of the horse is like either lived, died, or euthanized. So the first thing we're going to do is we're going to import our libraries after we've created our Jupyter notebook. Jupyter notebook is in my Kaggle account, and what I will do is I will put a link to the Jupyter notebook in the description box down below, so you can look at the Jupyter notebook if you want to. And then after we created our Jupyter notebook, we import our libraries, which are NumPy as NP. So that's going to create your NumPy arrays and also perform numerical computations. We're going to import pandas as PD, which creates your data frame and your series, and it processes the data. We're going to import OS, which is going to go into the operating system and retrieve the files. We're going to import NumPy as NP, which I've done that again. I did that a second time, which I didn't need to do that, so sorry. And we're going to import Matplotlib as PyPlot as PLT, and we're going to, which it visualizes the data. And we're going to import Seaborn as SNS, which statistically visualizes the data. We're going to go ahead and set our seed as np.random.seed42. So anything that needs to have NumPy in it, it will run the same because we've set the seed. We're going to load the files using OS. So this is going to retrieve the 3 files that are used in this program, being train, test, and sample submission. Then we're going to use pandas to read in the files, and we're going to read in the files and convert them to data frames of train, test, and submission. What I did was I set the options so you can see all of the columns of data. So pd.setOption display.maxColumns none. So that enables you to see all of the columns of data. If you don't do that, you won't see all of the columns in data. I checked, and you can see you've got 1, 2, 3, 5 rows by 29 columns. And then so we're checking the info, so you can see we've got some float, objects, and integer columns. We're going to check for null values. You see we've got quite a few null values. So I had a choice. I could either drop all the null values and train, or I could forward fill them. And so I got a better accuracy when I dropped the values than when I forward filled them. So I dropped all the null values. And so now we only have 771 rows by 29 columns. We check our null values again, so we see we don't have any null values anymore. Now we check test. The test file is the same format as the train file, except that it doesn't have an outcome, because the outcome tells you whether the horse lived, died, or was euthanized. We check for null values. You can see we've got 559 null values. So what we're going to do now is on the test file, we're just going to forward fill all the null values. So I had an opportunity, so I could have imputed them and put the median or the mean or the mode in there. But I just thought, well, I'll try forward fill and see what happens. But when you put the median and the mean and the mode, I mean, you're not sure exactly how it's going to work, and the forward fill is an alternative. It just puts the value of the next of a cell beside it. So there's not a lot you can do when you have missing values. I mean, ideally, you would just delete all the missing values, delete the rows that had missing values, but you can't do that in a Kaggle competition, so you have to impute them. So now we don't have any more missing values after we use forward fill. And then now our submission. So this is what Kaggle wants to see when we submit our work. They want to see either an ID or an outcome. So now what we're going to do is we're going to encode the label. So we want to print the unique values of the label so we can see what's there. So you've got died, euthanized, and lived. I used Seaborn to create a histogram of the label, so you can see you had more lived and then than anybody else, anything else, and then you had died, and then you had euthanized as your outcome. So that's a histogram of the label. And now we have our outcome. So I made a dictionary where died is 0, euthanized is 1, and lived is 2. And then so train outcome dot replace outcome in place equals true. So you can see now it's numbers instead of words. But I will say that in some algorithms it will accept words, but I just went ahead and did that anyway, because you don't know what algorithm you're going to use. So now we're going to define our target, which is the outcome. So target equals train.outcome. And now we're going to encode our columns. Said from sklearn preprocessing import ordinal encoder. ENC equals ordinal encoder for column in train. If train call.dtype equals object, train call equals enc.fitTransform call.values.reshape -1, 1. And then we do the same thing with test call. Test call equals enc.fitTransform test call.values.reshape -1. I can see I made a mistake there. It should not have been fit transform. It should have been transform. So when I complete this code review, I'm going to make that change. And who knows, with any luck, it might improve my accuracy, which is what we want. We want to improve the accuracy. So I did find a mistake that I made, which is why I like doing these code reviews. So like when you do a code review, you pick up things that you've done wrong. So it shouldn't be, the test shouldn't be fit transform, it should be just transform, but I'll try that out again. So now we're going to drop the ID. You don't need the ID, and the reason why is because all of the rows are automatically indexed in pandas, so you don't need the ID, so we drop it. We're going to use Seaborn to create a heat map. So you see that we've created a heat map, and it doesn't look like the columns of data are very highly correlated, so we don't really have to worry about that. So since the columns of data aren't very highly correlated, we won't worry about that. But if there were high correlations, then we could put code in there to check which columns of data are highly correlated. And you can either drop the columns, but if you drop the columns, there's a possibility that you'll lose accuracy. So it's up to you whether you want to drop the columns or not, but it's nice to see if any of the columns were highly correlated. But you can see here that just looking at the heat map, you can see that the columns are not highly correlated. Now we're going to define our X and our Y variables. So Y is your target, X equals train, X test equals test, and print Y.shape, X.shape, X test.shape. So you've got 771 in the train set and 824 in the test set. And we didn't standardize the data. The reason why we didn't standardize the data is because Naive Bayes, you don't need to standardize the data. It's automatically standardized inside the algorithm. So we just didn't standardize the data. But if you want to try to standardize the data and see which works best, then go ahead. But we did convert Y, X, and X test to NP arrays. So now what we're going to do is we're going to split the test set into training and validation sets. And so we're going to use sklearn's train test split to do that. Now we've got the Naive Bayes algorithm, and I will say that I did a medium article on the Naive Bayes Classifier in Python, and if you're interested in that, I would highly recommend that you read the article because it will explain the Naive Bayes Classifier. But what I will do is I'll put a link to the piece in the description box down below if you want to read it. But here's our Naive Bayes Classifier written in Python. It doesn't utilize any libraries. It's written strictly in Python. So you've got the initial function where everything is initialized, the init, and then you've got the classify function where you classify whether it's lived, died, or euthanized, or 0, 1, or 2. And then what we do after we have defined our Naive Bayes classifier, we use it, NBC equals Naive Bayes classifier, X train, Y train, and then what we do is we predict on it. And so ypred equals empty list for I in range len x val, because we're predicting on the validation set. Predict equals NBC classifier x val I, ypred dot append predict, and then so we print I for I and ypred. So you're printing ypred, and you can see whether it's 0, 1, or 2. And now what we do is we check the accuracy. We had only 55% accuracy, but when I correct those, when I make that modification, who knows, the accuracy might improve, which I hope that'll happen. Now we're going to predict on the test set. And we use Seaborn to make a histogram of the test set. And then we decode the label. So predictions equals PD.series predictions. The reason why you have to convert it into a series. Label equals 0 is died, 1 is euthanized, 2 is lived. And then predictions replace label. So you can see whether they were lived, died, or euthanized. Then we prepare our submission, and so this is the work that we are going to submit to Kaggle. So submission outcome equals predictions, submission.toCSV, submission CSV, index equals false, submission equals PD.readCSV, submission CSV, PD.readCSV, submission CSV, and then submission. And so this is what we have actually submitted to Kaggle. So what I'm going to do now is when I finish this video, I'm going to make that correction to the ordinal encode, and hopefully with any luck that will improve my score. That's what I'm hoping. It will improve my score. I'm also going to give you a link to the Medium publication that I made with the Naive Bayes Classifier in Python, so you can read about that if you are interested. So thank you so much for watching my code review. Thank you to my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. And I look forward to making more code reviews for you in the future.